Hello, welcome to another Entity Framework Community Stand-Up. I'm here with Jeremy, PM on the .NET Data team at Microsoft. Two of us today. Shai's out doing some other stuff. And today last week we had, or 2 weeks ago, we had Postgres stuff. Today we're jumping the fence and going into SQL Server and Azure SQL to look at temporal table support, which is newly supported in ES4 6.0. So that's what's coming up. Before that, let's go and look at the state of the unicorn. So it's all about 6.0. RC1 is on NuGet, like we told you last time. So feature complete, pretty much. There was one feature going into RC2. But we need your feedback. So go get it now or get the daily build, which I'll come back to in a second. We have updated docs now for what's new. So I'm going to show you that. So this is in our docs page. So .NET, what is it, Jeremy? What's the URL for the docs page?
You mean the show notes?
Yeah, well that'll do because we'll put it there. But I was thinking,
yeah, I actually have a banner.
Microsoft / something, right? Yeah.
Yeah.
Okay, there we go. There's a show notes, so you can find all the links in here. Okay, so this is what's new. There's fairly substantial documentation. Apparently 68 minutes if you try and read it all. We've got SQL Server Temporal Tables here. There's actually a different sample app, which is also on GitHub. We have a section on migration bundles, pre-convention model configuration. We've got some documentation on compiled models, including how it's bootstrapped, and if you want to do multiple compiled models and choose a different one at runtime for if you've got different schemas, there's how to do that. We've got some information on the improved performance of Tech in Power Fortunes, lots of Cosmos provider enhancements, so implicit ownership there, collections of primitive types, new translations to built-in functions, a lot of those. Raw SQL in Cosmos, distinct queries. We've got more diagnostics coming out of logging for Cosmos. You can configure throughput, you can configure time to live, and you can resolve your own HTTP client factory. So lots of stuff in Cosmos. Improvements to scaffolding. So we now scaffold many-to-many relationships. And we now scaffold with C# nullable reference types. If your project's using those, we automatically detect that. Database comments are scaffolded. So if you've got comments in your database, those can go onto your entity types. Improvements to link, group by. So with more group by, there's several examples, 3, 4, 5, 6 examples, 7 example, 8 examples. I put them in and I've forgotten. 9. Wow.
9. It keeps
9
going.
examples. Those are actually taken, those examples were taken from queries that customers have posted. So I took those queries, massaged them a bit and put them as examples in here. So real life queries in a sense. Okay, also in link, translation of string concat with multiple arguments. We've ironed out some of the usability edges with system link async if you're using that. Free text search is better in SQL Server. We translate toString on SQLite. We've got EF functions.random. We improve is null or white space translation. We have a defining query for the in-memory provider. It lets you simulate views in the in-memory provider. Translate substring with a single parameter. And we now do split queries for non-collection, non-navigation collections. So when you're projecting a collection in your query, we can use a split query for that. And there's several examples of that. And then we also a perf improvement where we remove the last OrderBy clause when you're doing these split queries, so that can improve perf in some cases. Also, you can tag queries automatically with file name and line number. We have a tag with call site, so that's cool. And then some things here about optional dependency handling and when things get materialized and when they don't get materialized and all that stuff, and some changes we made and warnings we're putting out there. We've got new mapping attributes, so you can put Unicode attribute on, you can put precision attribute for precision and scale. We've got an entity type configuration attribute. You put it on your entity and it tells it what entity type configuration to use for that type. So more model building improvements. So we support SQL Server sparse columns in model building and migrations now. Improvements on the has conversions API. It's easier to use. You can use the generic type to put your converter directly in there, which is very useful. You now use less configuration for some many-to-many examples. For example, you can just put a using entity without specifying anything else, and we'll do things by convention there. We allow value converters to convert nulls, although we found several issues in testing this, and so this may become experimental for SIG. So we're not going to move it, but we're going to kind of put it behind the flag just so people know that there's some issues using that. See more on that in the coming days. We've improved the DB Context Factory. So when you add DB Context Factory, you also get a DB Context in DI automatically. So you'd have to call both of those. We can, when you're using the factory, you can have both a parameterless constructor and a constructor which takes options. That didn't work before because of the way the resolution was working in DI. You can use now context pooling with a factory without using DI. So we've had context pooling for a while, but you had to be in DI. Now you can essentially create your own pooled DB context factory and just grab context out of it, and they'll automatically be created and then pooled. And when you dispose of them, you can then get another one out and it'll be reused. We've got some EF Core minimal API that goes along with the ASP.NET Core minimal API. And we now preserve synchronization context in save changes async, which might be important to you if you're doing a UI application. In the in-memory databases, now validates that you don't save null into required types. And we have command source information for interceptors. So for example, if you just want to intercept things from save changes, you can easily filter that out and say, just don't ignore anything that's coming to my database except for save changes. We've got some better handling for temporary values where you can actually put them in the entity type and manipulate them more easily. The entire EF Core code base is now annotated for C# nullable reference types. So when you use that in your code base, you'll get all of the correct stuff for whether things can be null or not. We're also shipping Microsoft Data SQLite, which it's got connection pooling, which is awesome. Support for data only and time only. That goes through EF Core, and we also got Postgres support for that. And I believe MySQL support is coming for that too. On SQL Server, we have to wait for SQL Client to implement that, so it's not in SQL Server yet. SQLite has a save points API. You can put the command timeout in the connection string, so there's a connection timeout, but some people don't always also realize that ADO has this command timeout, and you can now put that in the connection string, and that's it. So that's a whirlwind tour of
Wow.
what's in EF Core 6.0. Lots of
So,
stuff there, examples on GitHub. Go, Jeremy.
so it sounds like the teams added 1 or 2 features to EF
Just
Core
one or two,
6
yes.
is,
And the
is what I got
community.
from that.
Some of those I didn't stop to do it because I wanted to go through fast, but we call out those things that are implemented by the community there as well. So many thanks to those people.
Nice. Yeah, they're part of
So
the team.
why try waste RC1 or wait for RC2 when you can get GA now? What? Okay,
Huh?
well, it's not really GA, but our daily builds are on GitHub and they're easy to find. Just go to our GitHub homepage, which I'm gonna. Oh no, not there. You see, I'm getting confused with my screens here. That's because I want to go directly to
Looks like you
this
have a
one.
tab already. No?
Yes,
Yes.
that's right. I have a tab. Right, so this is just the homepage, .NET EF Core. If you scroll down, daily builds. Click on daily builds. It tells you what to do in great detail, but it's really easy. Basically, you need this file called NuGet config, and you just put that in the same directory as your solution. So I'm actually going to do today's demo on the daily build. And so this is what my NuGet config looks like in there. Oh, no, that's what my CS project looks like. That's what my NuGet configs looks like. So it's got nuget.org, and then it's got this link here, which is in the daily builds documentation. And it says just pull in the packages that we build. So every time we basically push to the release 6.0 branch, you'll get a new build of that. And then you'll be able to see when you go into your CS proj, I have here RTM version 21.503, which was probably from yesterday or a couple of days ago, I'm not sure. And this gets updated multiple times a day usually. And it's not quite GA because we're still making a few bug fixes, but we're basically locked down now for 6.0. The only things that are going in have to get, approval from the directors, and they have to be like critical bug fixes, so we're really stabilizing. So this is basically what you're going to get when we release GA in November. So if you want to get the latest and greatest, obviously doesn't have a license, so it's used at your own risk. But if you want to get all the best stuff, then try the daily builds. And that's it for State of the Unicorn. So I think, unless Jeremy has anything else or any questions.
I wanted to show this question really quick. So, are there any auto transforms to migrate from EF legacy to EF VNext and analyzers to guide devs what they may be doing wrong? So, this is actually very timely because one of one of my focuses, is to build out more comprehensive guidance for migration from EF6 to EF Next. And we will be rolling out some new documentation. And honestly, if it makes sense to look at tooling in certain places, that's something we'll absolutely consider because we want to make that experience as easy as possible. So thanks for asking that question. And it is being worked on right now. So it's
Awesome.
a priority for sure.
Yeah, and if you have issues if you have migrated from EF6 to EF Core, or you do it, let us know what you run into, because we don't always we obviously talk to a lot of customers and see a lot of things, but it's always great to get feedback from people actually doing it and finding out what you hit and what was difficult and what was easy and all that kind of stuff. So let us know.
What Arthur said.
Okay, so temporal tables. So what are temporal tables? Well, basically in SQL Server, when you create a table, normally when you then insert a row and update that row, what the data was before you updated it, has now disappeared. With temporal tables, SQL Server will automatically keep a history of every change you make to that table. So you can normally just use the table as it were, just use it as any regular table. But if you need to, you can go back and look at the history of all the changes that have been made to data in that table. So that's useful for auditing, and I expect that's the main reason most people use it. You don't have to figure out what changes were made to a table. You can go look what changes have been made to the data in that table. But it's also can be useful for doing diagnostics and forensics, where you're going back and trying to figure out what went wrong somewhere. And also, if you accidentally lose data, something does a direct data corruption and deletes something it shouldn't, or change something it shouldn't, then you've got the data there to restore it. So I'm going to show some of that today using EF Core 6.0, which has support for temporal tables. So EF Core can both do migrations to create the temporal tables, and then we've got link operators that allow you to query for that historical data. Okay, basic model. So we have a really simple model just for the sake of demonstration. We've got a customer, and the customer has some orders, like so. Each order has a product and a customer and a date. And the product just has a product name and a price. It's a terrible data model, as we'll see as we go through the demo, but it shows a lot of the things that you can do with temporal tables. So in our setup for our context, this is just a normal DB context here. We've got DB sets for these three things. I'm using simple logging, and I pass a parameter to the constructor to log when I want to. So when in the parts of the demo where I want to show the SQL output, I just construct the context with this logging turns on, and then it's going to write SQL out to the console using simple logging. In on-model creating at the moment, I haven't done anything. So I'm going to create the database initially with not temporal tables, and then we're going to uncomment this and see what changes that makes. So let me go over to my terminal window here. And we're going to do a .NET EF migrations add initial. So we're just going to create this model in the database with migrations. So let it do that. And then I'm going to do a .NET EF database update. Excuse me. And that will create a database that we're calling orders. So I've got SQL Server Management Studio open here. So let's go into the databases and let's look at orders. So here's our orders database. As expected, we've got three tables: customers, orders, products. If we look in customers, we've got the columns we expect, PK, we're using GUIDs, and a name for the customer name. So pretty normal database there. Okay. So now if I want to enable temporal tables, or system version tables, as SQL Server calls them in some of its documentation.
Calls them what? System
version tables, I think.
Got it.
We'll see that in Management Studio in a second. All I have to do is do in the API is temporal on it. So to table, and then in the nested builder for table properties, we're making it is temporal. So let me do that. Let me add a new migration. Make temporal. Of course, it's asking me if I want to add my migrations to Git. Okay, so we've created a new migration. I'll do a database update again. Okay, so now we're going to do a blog post on this probably in the next week or so, and in that we'll actually show the SQL that was used to do the alterations. I'm not going to show it right now, but basically we did a bunch of alter tables. So if we go back here and let me refresh the orders database, if we look at the tables now, you can see that these all say system versioned after them. So that's basically says that they're temporal tables. So now we go in and look at them, we'll find some interesting things. Let's look in the columns again. So now you see we've got these two columns here, period end and period start. And these are date time 2 columns. So this basically says this is where this is the time that the row was active from, and this is the time when the row was active too. So every time that you make a change, these will automatically get updated. They're computed columns in SQL Server. In addition, and this is kind of the cool bit, there's now this customer history table, which has been automatically created behind it. And if we expand into this and look at it, we can see it actually has the same columns as our main table. However, there is an interesting difference, which we'll come back to later. The ID column is no longer a PK. So basically the constraints have been removed. And that's because this is going to have multiple rows for the same PK. And so you couldn't have a PK constraint that would make those unique. But what SQL Server is going to do is every time we make a change to the customer table, it's going to copy the original data that was in the customer that row in the customer table into the history table. So then the history table essentially has rows for each change that we made, and the period end and period start columns for those rows will tell you when that data was valid from. So if you make a change and then 2 days later you make another change, it'll be valid for those 2 days, and the period start and end will show you that. So that's basically what temporal tables are. There's some configuration that you can do as well. So we love nested builders. I hope you don't hate us too much for it. But you can go into a table builder, a temporal builder, I guess I should say here. And we can say, okay, well, I don't want it called period start and period end. So I'm going to say has period start and then give it a different name. Let's call it from. And likewise, I can do period end and call it to. I can do use history table to give the history table a different name. All the old stuff or something like that. Okay.
We had a question pop in. Is
Okay.
it going to break your
No, that's fine.
flow?
Yep, go for it.
So why is in period end not null? Surely the latest row content would have an open-ended end.
Yes, we were going to see that later, but in fact, what it has is the date time to max value in it. So it's basically valid from now until the end of time.
Morrissey beat you.
Maurice. Oh, Maurice's here. Nice. Thanks, Maurice. Maurice's the person who, developer on EF, who did all this work. So many thanks to Maurice for this awesome stuff. I had it in my notes to say that at the beginning, but I forgot. So I'm glad he popped up there. Okay, so I've changed the names of these columns in this table. And of course, we've got migration, so we can just change that. So change names. Yeah, add the migration database. Okay, let's go back and look at Management Studio again. I'm going to refresh this table if I can. Okay, there we go. Okay, so now, which one did I change? I can't remember. Customer. I changed customer. Okay, good. So now customers, if we look in the customers table, look at the columns, we've got from and to instead of period start and period end. And our history table is now called all the old stuff. And it also has from and to in there. So you can control those if you want. For the sake of simplicity, I am going to go back to just the defaults that we had here. So I'm going to delete this code now that I've shown it to you. Okay, so we delete that, and then what I'm going to do, I mean, there's various ways I could revert the database at this point, but what I'm going to do is say, okay, so this was the migration beforehand. So let me copy that. So migrations can go up or down. So I can do .NET EF database update, and then put in a migration name. And I'm going to put another one. And when I apply that, oh, what did I do wrong there? Oh, I put
You don't have a closing quote.
Yes, so
You're
to get
in
out
your
of this
code now.
Live coding. So let's see, can I do that? No, why is it not letting me do this? Oh, I think I'm clicking on the live stream rather than I'm getting confused.
I
So
can't get
close
past the
quote.
glass.
Okay, yay, did it. Make temporal not found. Okay, that's because I have to not have the quote in there. So let's do that again, but without the quote. Oh no, I've copied something else now. This is all going wrong. Okay, not found, not found, not found. Here we go. Going to be careful with my copying this time. Okay, .NET, EF, database, update, paste that. Okay, so now we've rolled back the database to the previous version, which is easy to do if you can copy and paste, right? So let's just check that again to see that we're back to where we were. Tables, customers, and indeed customer history is the way it was before, and the columns are period end and period start. Good stuff. Then I'm going to also remove the migration that I don't need anymore. So .NET EF migrations remove. Okay, so that's migrations for creating temporal tables, updating an existing table and making it into a temporal table, changing the period column names and the temporal table history name. So now we're going to actually start playing with it, unless there's any questions we should take before that.
I'm just going to show this. There was a question, if I want to track who made the change, do I just add a user property to my table? And then the response deals with the creation, modification, deletion of rows, any other information you would need to code yourself.
Yep. I think that's exactly right. Thank you for that. Okay, so let's go look at program I have here with some examples. So first thing we're going to do is we're going to make some history.
All right.
It's a little difficult to demo temporal tables because you need to have changes over time. So I've got a thing that I pass here, sleep, which basically says, okay, right, let's create a customer. Let's create some products. So we've got a Delorean, a flux capacitor, and a hoverboard, and they have some prices. I don't know why I picked these names. It must be some movie I saw sometime. I can't remember. And then after we do each save change, we call him asleep so that we get some delay, some history between each change that we make, so we can actually look at them. By default, I've set this to a second, so it doesn't take very long. If you all this code is on my GitHub. It'll be in the show links where it is, so you can download this and play with it. And if you want to make it a bit easier to see the differences, you can increase that timeout. So basically what we're going to do is we're going to change the price of the DeLorean and then save it and then wait and then change it again and save it and wait. And then at some point, I'm going to make a purchase of a DeLorean. I don't know why I did that, but anyway, I did it. And then we're going to start changing its price again and so on. And then we're going to return these timestamps from there just so that we can then play with the data by knowing what time it is. So I'm going to run that, and hopefully what we'll see is it takes a little while because it has to do a second pause between each one. So, a few seconds. Okay, so it's run that, and then I've run this code. You can say it's saying the current price of the DeLorean with this is the PK for it is 150,000. It's pretty good deal there. And all I'm doing here, I'm just using the table as normal. So I'm doing a single because there's only one product with this product name. Even though we've got history, that doesn't change the fact that in the main table that we use normally, there's just one product with that PK. And so I'm getting it, and I'm just printing out what its name is. So that's cool. Well, what about we want to look up all of the history of the prices on the DeLorean? Now we can do that because, as I've been telling you, we've saved the temporal table data, all the changes into that history table in SQL Server. So I have a query in EF that will do this. And the way you look at temporal data is we have these new link operators, and one of them is, they all start with temporal, and one of them is temporal all. So we're going to do that first, and that basically says give me all of those rows in the history table.
We had a request if you could increase your font size slightly.
It's pretty much as big as I think I can make it. I'm sorry. Okay. I mean,
yeah. Here, we'll do this.
And yeah, that probably makes it easy. You don't need to look at our pretty faces right now. So I'm going to do an order by to get them in the right order. We'll come back to that in a minute. I only want the products where it's the name that I'm asking for. So in this case, I'm going to ask for Delorean. And then what I'm going to do is I'm going to make a projection into an anonymous type here. And we're going to project out the product. So this is going to be a snapshot of the product in entity at the particular time. And then we're going to get the time it start, the data in that row started being valid, so that snapshot started being valid, and the date when it's ended being valid. By the way, all of these are UTC times. These are generated automatically by SQL Server, and the times are all UTC. And yes, I was just going to say these are shadow properties. So actually, let's take a quick look at that so you can see. So shadow properties are properties that are in your EF model, but they're not reflected on your CLR type. So so in this case, the product CLR type doesn't have a period end and a period start property on it. Instead, they're just stored inside the EF change tracker, and you can use them in queries, even though they're not part of the CLR type. And you can see that if we go in and use one of my favorite features, which is in the model, we go into the debug view, and we're going to look at the short view here. And you can see that this is the customer endpoint. So this is like a dump of what the model looks like. And you see we've got the period end here, and it says it's your shadow property. There's no field because it's not in the CLR type. And this basically says ignore it as far as EF is concerned. So you never make changes directly to these things. You can't, like, say, update the period end to change history and make it this. These are just computed columns that you get back. And the same is true for orders and things. Now, shadow properties are used in plenty of other places too. For example, I know you may not have noticed, but in my entity type for order, I had a customer navigation property. So that defines a relationship to the customer, but I didn't actually put a customer ID FK. So we have a shadow property here for the foreign key. So quite often when you're using shadow properties, they're for foreign keys, but in this case, we're using them for temporal tables. The long view in the debug also shows annotations, and usually that adds a lot of noise. But you can just see here that we've annotated it to say the table is a temporal table. That's how it's built into the EF model. Okay, so run that, and this is let me run it again just without the debugger here. So what we're going to see here is that we're basically going through, and oh no, I've gone too far there. We're printing out the PK of each of the products that we found and its price at that particular time and when that was valid from and to. So we've got that data here, and I want to point out that all of these have the same PK. So you remember when I showed you that table in SQL Server Management Studio and I said it doesn't have the PK constraint on it? Well, that's because, like, this would be a PK violation in the normal table, but in the history table you have all of these things. And it's kind of important to understand that when you're looking at the history table, your data model, the constraints that you have on your normal data model, don't really apply to the history table. You have products with the same primary key with multiple entries. So if you've got relationships to customer, then over a certain date range, there might be multiple customers, there might be multiple orders when there would normally be one. So that can make it a little bit tricky to deal with, and we'll show more of that later. Okay, let's come back to the code here. Now, we have this order by. So in the same way that we use the shadow property, you can use this EF property, by the way, for any for any property. It doesn't have to be a shadow property, and it can be quite useful if you want to do some dynamically generated things and you just want to use the string for a property name. So I could make this ID, for example, and then it would pull out the ID, and so that's nicely useful. But mostly use it for shadow properties. And we're using it here to get the period start in the query. So not only in the projection, but you can use it in generation of the query. And we're doing an order by here. And the reason for that is one of the things that I've run into. If you don't order it and then rerun it again, SQL Server outputs the data in a fairly confusing way, to my mind. It's probably not defined, by the way, so if I added more, the order might change. As always in a relational database, if you want an order, you have to explicitly specify what that order is. But you can look at this. What it does is it puts the current data first. So that's the one. Oh, remember we asked about the not null? So this is valid until 12/31/999/1159, after which it's not valid anymore.
The software industry is going to have their work cut out for them on 9,999.
Yes, the year 10,000 probably.
10,000 is going to be something.
So it does that one first, and then it goes and does all the history. So it's like this one is really kind of out of order, and that confused me because I'd look at this and why isn't the last one there? And then, oh, it's at the top there. So that's why we have that order by there in these things. Okay, so temporal OR gives you all of the history. Often you might not want all of the history, so there's these other operators as well. There's temporal from to, temporal between, and temporal contains in. As of, we'll come back to later. These basically all do the same thing, except there's different boundary conditions on what it includes and what it doesn't include. You can look at the SQL Server documentation. We'll put that in the show notes too. There's a link to it in my blog post, Jeremy, if you want to put it in the show notes. But the SQL Server documentation explains what the difference is for between, from, to, contained in.
Okay.
We're just going to do from, to. And I'm going to pass in from, to that are passed into my method. So that's why every time I run this, I'm recreating the history table so I can get the exact times to put in the from, to, because we're creating the history very rapidly. It's not, you can't say from this day to that day. It has to be from this second to that second. And so that's why for the demo, I'm passing these two things in. So basically when I call this method at the top here, I'm giving it timestamps between 1 and 3. When we're doing save changes, we were putting a timestamp in between each one. So if I run this now, we won't get all of that temporal data. We'll just get a couple of them, I think. Let's wait for history to be made again. There we go. So we just get a couple of them. So it's filtered it out for those particular date range. So if you're doing like, forensics on your database and you want to know what happened on this particular day, something happened between these hours on this day, you can go back and look at the changes that happened right then. Okay. So as I said, I ordered a Delorean and I don't know why I did that. So I called customer service and I'm like, I don't want this DeLorean.
Oops.
Can I return it, please? And I'm a very good customer at this store because I buy flux capacitors all the time. And so they looked at my history and they said, "Fine, you don't want the DeLorean. We're sorry. Maybe the brushed stainless steel isn't your look. So we'll return it for you." And so I'm like, get off the phone. I'm like, awesome, they're going to return it for me. So now, customer service have run the query that they've been given by engineering to find out how much the DeLorean costs, and it comes back and it says, let's see, we've got to wait for history to be made.
So I guess returns mean something different for a time machine shop, huh?
Oh, I never thought of that. That's good. Yeah. Okay, so it's telling me 150,000 is how much I pay for my DeLorean, and so they send me input email and say, yeah, we'll refund you 150,000. And I'm like, what? I didn't pay 150,000 for it. I paid $2.5 million for that DeLorean, and I do not want 150,000 to be put back in my account. So why is that? Well, it's because engineering have a terrible data model, as I said earlier on. And so when we look at this find order, what I'm doing here, I'm assuming for safe simplicity, there's one order per day. So basically, you're giving us a date that we ordered, and then I'm searching for where the order date is on that particular date, just normal order for me. And I'm including the product and the customer, and then I'm saying, okay, this customer ordered this product for this price on that date. But as you've known, we've been updating the product. So even though when I ordered it, the product had a price of a certain, had a price of 2.5 million, by the time customer service run this query, the price is now 150,000, which isn't what I paid. So basically, I think customer service would be onto engineering. So you need to change that and make it have the price that the person actually ordered it. And they're like, yeah, fine, we can do that. But what do we do now? Right, so what we can do is we can go back and actually use temporal table features to figure out what the data was at that time. So I'm going to use this other operator, temporal as of. Now, temporal as of is different from, what's my time called here, on. It's different from the other operators that we've looked at because it says, at this specific point in time, tell me what was in the order table. And that's important because at a specific point of time, your model is valid, right? So at a specific point of time, you've got an order, it's got one product, it's got one customer. So that means in EF, we can use things like include to bring in other things, and we'll look at the query that generates, but it basically means I can use the full power of EF to bring in everything I need. If you try and use include with, for example, temporal all or temporal from to, it's going to say you can't do that because it gets really messy, because you could have one product in your model, but there's actually 10 products that get returned for that time period. So what do you do? So we don't allow that in EF Core, and I think that makes sense. If you feel otherwise, feel free to contact us and explain your use case and how it would work and everything. But I've thought about it a lot in the last few days, and I can't see how it would work well. But when you're using temporal add-on as of, because you've got a specific point in time, you can get that. So let's run that. And it should give us back at the time that I made the order. It should give us actually any time in that period, any time, between the two times where the order was in that valid state and the product was in that valid state. Okay, here's the query that we're running. Well, first, it says I paid 2.5 million for it. So I'm happy now because I've got my 2.5 million back. The query here, it's as you'd expect, it's just pretty normal type of query. We're pulling in the period starts and period end columns. By the way, these are hidden in SQL Server by default, so you won't normally see them, but we pull them in so that we can populate the shadow properties. And then it's using the SQL Server feature for system time as of. This is what our temporal as of operator translates to. And we're saying, as of that time for the customer, but also for the product, and also for somewhere up here for the orders. So basically, it's saying, be consistent at that consistent point in time. Bring me back from all these 3 different tables what the data was at that particular point in time. So then that allows it to say, okay, the order pointed to the product which had this price at that particular point in time, and customer service can give me my money back.
So how much is that in pounds? Can you do the math in your head?
Oh, like 2 million maybe. Yeah. I can't really afford a Delorean, by the way. If I could, I still wouldn't buy one. Anyway, there is a Delorean that drives around Redmond, though, in Microsoft campus near Seattle. So it's kind of cool when you get to see that. Okay, so that's basically shows us. So we've looked at how we can see all of the temporal data. We've looked at point in time. As a customer, I'm not particularly happy with my experience here, so I called them and said, just delete my account. I'm not buying stuff from you again if you can't even get this simple stuff right. So we've got a method here which is going to delete my account. SQL Server, when you use temporal tables, it doesn't allow you to have cascade deletes on the tables. So we would normally probably have a required relationship between customer and orders. If you delete the customer, it automatically deletes the orders. That won't work directly in SQL Server. There's various ways you can do it in EF. You can still use cascade delete on the EF side and then edit the migration to not have it on the SQL Server. Then you can load all data and it'll do the right thing. But for the sake of simplicity here, what I've done is I've just loaded the customer's orders and I've set all the orders to state deleted. I've set the customer to state deleted and I save changes. So now if I run that, my account is now deleted, which is great, except I then realize I need a flux capacitor and there's nowhere else that I can buy a flux capacitor. And, the reason they even gave me my money back is because I bought so many flux capacitors. I don't know if you know this, but they burn out really, really easily. So if you want to get back to the future at any point, you have to pretty much get a new flux capacitor. That's been my experience anyway. Okay, so let's run a query, simple query here where again I'm just doing temporal all on the customers table this time, and I'm saying let's find the customer, and it's going to print out for the customers on here. It's going to print out what we have in the history table. And so this is going to be pretty much what we saw before. What we should see is one row, because there's only one customer in this database, and it has the customer here existed from 543 until 543 and 36, and then the order also, because we deleted the orders, that existed for a slightly less length of time. But because this isn't date time 2 max now, that means it's gone. So if we were to query the customer table, we wouldn't find any customer. Query the order, we wouldn't find any orders for that customer. But customer service gets onto engineering and says, right, this customer wants his account back. How can we do that? So again, it's probably not the best way to manage your customers and orders in a real database, but assuming we have this, we need to go in and see what we can do. So what we're going to do is we're going to query that temporal table and then we're going to write it back. So we're going to basically restore some data that was accidentally deleted. It's a little bit tricky, and temporal tables can be a little bit tricky because of kind of the figuring out when getting the consistent data and making sure that you can pull in the correct orders at the same time. So what I'm doing here is I'm basically running one query to find the time that the customer was deleted at. So what I'm saying is give me all the history for this customer name and order it by the period end, and then just select out that period end and give me the last one. So basically this is saying, give me the last time that this customer was valid in that table. Once I have that, I can now use temporal as of for that particular period in time, include the orders, and we'll come back to this in a second, include the orders, and then to restore it, I just need to say to EF, add that to the context, sets that everything is tracked. It's an does an add graph, so it'll add all the orders as well. We're not using generated keys, we're using GUIDs, so the keys will be, it will set it all to added state automatically, call save changes, and it'll write it back into the main database. Why do we have this add milliseconds -1? Well, when you do temporal as of, it doesn't include something that's on the period boundary. Sorry, doesn't include something that's on the. So if you've just got the period end time, it won't be included in temporal as of. So originally I thought, oh, well, I'll just use period start, right? And that's fine, except the period start for when the customer was created, which was right at the beginning of our seed, is before the order was created. So if I do that and then I say, okay, temporal as of that time, then I don't get the orders because the order was created later. So essentially, the way I found to do this, and if you know how to do this better, then let us know, is to say, right, well, let's just go to just before, so 1 millisecond before the things was deleted. So that means that temporal table as of will return it, and then we get the orders that were there at that time too. So hopefully that makes sense. So let's go back to the top here. Let's see. We'll run that, and then we'll run the same query that we did before that will show us our customer and order history. So we make some history. And then run through everything. Okay, so now you can see that there's 2 entries in the history table, and this one again has the 900 and year 10,000 basically. So now, say I existed from this time to this time, and then I was restored, and I now exist again. So now my customer record is back in the database, my account's restored. All my existing orders, which there was only one, have also been restored. And so we're basically back to where I was, and I can go ahead and order my flux capacitor. So that's essentially how you can go back and query some old data. Maybe you've had data corruption, something was deleted that wasn't supposed to, and then you can restore it. So again, I wouldn't use this as this is how we manage our data. Personally, I would design the business model in a way that would allow that to happen better. But certainly, it can really help if you get yourself into a state where you've got data that was deleted that shouldn't be deleted. And I guess if you do it carefully enough, then what with the temporal tables, you could probably build it into your business model as well. Although I don't think I would do that. So that's all I have for temporal tables. It's a very powerful feature, pretty easy to use, some gotchas, but yeah. We have
Yeah, so we have a few questions and answers. So one is great question. What is the performance implication? And we've got basically, we need to do some testing on perf, but little impact. Basically, see this data, you should expect a perf impact. It's basically stored in a different place. We're assuming there's a little bit of overhead because it's a double insert, right? Because it has to insert the audit. But this kind of ties into the next question, which is kind of what are the pros and cons of this versus doing it yourself? And I agree with this, right? Convenience. It's AUT-O-matic, and now that you can use EF Core to actually query and restore and do things with it, it makes sense not to reinvent the wheel, right?
Agreed. So on the perf thing, I definitely have seen people comment that queries on the history table can be slow when you've got a lot of data in there. And so I believe you could, as we saw in SQL Server Management Studio with their tables, you may want to add indexes, whatever, on there to make those faster for what you need to do. But I agree that I don't think there's a huge impact of using the normal table. In terms of the second question about roll it yourself, I think one of the big advantages of this is you can't get it wrong. I mean, there might be a bug in SQL Server, but this has been out for quite a while now, so I think that's fairly unlikely. So you can't suddenly find out that you're missing audit data or whatever. It's like it's there, it's built in. Whenever somebody makes a change, whether they do it through EF, whether they write their own query on the command line, whether they fire up Management Studio and make a change, there's no way they can just accidentally get this wrong. It's going to be in that history table, and I think that's a big advantage for auditing.
I feel like that's my whole history of software development is spending hours or weeks or days implementing a feature and then refactoring it to use something that comes out of the box. You'd think at this point in time, all of our software would be like 5 lines of code because everything's been figured out, but it doesn't seem to be the case.
Yeah, I would also say though that I think, there's a right way to use this and the wrong way to use this. So having if you're running an online store and your orders contain references to products where the product price has changed and you haven't snapshotted that price in the order, that seems like just a bad business model to begin with, right? So
Sure.
the correct thing to do there is make sure that when you query the order, it has a snapshot of the price that the person paid at the time they made the order, and not try and have people go back and look in the history table for that. So I think there's right ways and wrong ways to do this, but certainly if you're looking at, I just want to record every change that's made to the data so that it's there for auditing, and so that I can do forensics on it, and so I can go back and restore stuff if things go wrong, definitely very good for that.
Awesome. And there's also that nuance of time, right? Understanding that it's time stamped with the server time, and
Yep.
that things can happen across time zones. And we actually have a upcoming community stand up where we'll be talking about know the time. So we're going to get
Yep.
to know the time in that stand up.
We've got John Skeet coming on the show. So if you're on Stack Overflow, you've probably seen John Skeet answering stuff. So we're pretty excited about seeing that, talking about that. Anything else in the questions, or are we done?
Not seeing anything else. I will note that we stream out to YouTube, Twitch, and we just added Twitter. So we were broadcasting live on Twitter.
Oh, right. I didn't even know that.
And I thank the two of you who have been watching us on Twitter. We appreciate growing our audience. So awesome.
Okay. Okay, well, I guess we'll end there. And do you know what we have in 2 weeks, Jeremy? What's the next one?
I can tell you because it's already scheduled. And what I do is I go to live.net. I'm pretty sure it's the Noda time, but
I think that's 4 weeks from now.
Is that 4 weeks?
November 3rd, I think that one is.
Okay, let's see. EF Core with ASP.NET Core. Yes, we have Rick Anderson
nice.
And someone else from the Docs team. I apologize so much because he's just starting, so I don't have the name. But they're going to talk about ASP.NET Core and EF Core in a back to the basics talk, just getting to
Awesome.
foundational.
Sounds good.
I'm building a web app and want to use EF Core. Here's what we do.
And Rick's the person who on the docs page has the getting started with Razor pages and EF Core and MVC and EF Core and all those great, multi-part tutorials. So really looking forward to that. Okay, well, thanks everybody, and we'll see you in a couple of weeks. Bye.
Thanks, everyone.